A symistor or a triac is a semiconductor device used for commutating load in AC circuits. It is a bidirectional thyristor with 3 electrodes, a control electrode plus 2 main electrodes that conduct operating current. A symistor can conduct current either from an anode to a cathode or vice versa. Unlike thyristors, a triac can be controlled by both positive and negative current between the gate and T1. This is why a symistor has 4 operation modes or quadrants, namely 1 plus, 1 minus, 3 minus and 3 plus. 1 and 3 stand for current voltage characteristic sectors. Plus and minus indicate the polarity of the gate. This is the working principle of the so-called four-quadrant symistors, also known as 4Q triacs. Low voltage signals applied to the control electrode are used for adjusting operation modes of a symistor. A triac opens if trigger current passes through the control electrode, or if the voltage between its power electrodes T1 and T2 exceeds a certain maximum value. In the AC power mode, a symistor changes its condition with the change in voltage polarity at the main electrodes T1 and T2. A symistor changes to an off condition after the polarity between outputs T1 and T2 has changed, or if the value of operating current is less than the value of holding current. In standard AC phase control, the gate and T2 always have the same polarities. This is the case brightness controls and devices controlling rates of rotation. It means that control function is always carried out in quadrants 1 plus and 3 minus. There the commutating parameters of the triac are equal and the gate is most sensitive. 3 plus is the least effective quadrant of put switch in the triac. There are several reasons for this. Due to the peculiarities of symistor gates, design the gate is least sensitive. This quadrant has the greatest delay between the moment when the gate current starts running and the triac changes its condition to a conductor. The lowest rate of load current rise limits the critical parameters causing the triac to burn out near the gate. This happens when it has to control loads with high starting currents, for instance, capacitive loads and incandescent lamps. To avoid misoperation of triacs caused by noise and strokes created by motors, circuits using four-quadrant 4Q triacs must have additional protective components. As a rule, this is a damping RC chain between the power electrodes of the triac. It is used for limiting the speed of voltage change. In some cases, inductance is necessary to limit the speed of current change at the moment of commutation. These components increase the cost of the device as well as its dimensions. Besides, they can also reduce its reliability. The difference between a 3-quadrant or 3Q triac and a 4Q triac lies in the non-critical structure of gate overlapping. This doesn't allow carrying out control functions in the 3 plus quadrant. However, it also excludes the possibility of malfunction and helps avoid many problems associated with 4Q triacs. Firstly, 3Q triacs have better performance capabilities. Secondly, in most cases it is possible to do without a choke and a damping chain. Most devices work in quadrants 1 plus and 3 minus phase control, or in quadrants 1 minus and 3 minus unipolar control with the help of integrated circuits and other electronic circuits. Thus, the inability to carry out control function in quadrant 3 plus is a small price to pay for all the above mentioned advantages.